All right, let's look at the distribution of sample means. First of all, let's say that we asked our class of 30 people, how many hours do you study a day? Okay, and we got our results, and we found that perhaps our mean of this population of students was equal to 2.7 hours a day. And we found our standard deviation here was equal to 1.2. This would just be an example of data that was collected. Now from this, let's take the 30 people in the class, our population of our class, and take a sample size from this population of size n. So from the sample of 5 from the population, how many 5 samples are there within our population of 30 people? So this is actually just trying to figure out how many different combinations of 5 samples can be taken from 30 people. So this is a combination. And N and CR, where our N is 30 and we're going to choose 5. And we want to find all the different combinations here. So if we do that, there will be 142,506 different 5 samples that we can take from a population of 30 people. Now that's a lot of different samples. Each of those individual samples, each of the different 142,506 samples, they each have their own mean and their own standard deviation. So what we're going to take a look at in this section is finding the distribution of the sample mean. So the mean of all of the sample means. So instead of having 30 data of a population, we have 142,506 different data values from the samples. And what that ends up doing is it will create a better distribution. So since there are a large number of sample means, whether our original population is or is not normal, the distribution of all the sample means will become normal as the sample size from the population increases. And this is called something very special in statistics, so let's take a look. So the central limit theorem says, regardless of the shape of the underlying population, the distribution of the sample means becomes approximately normal as the sample size increases. Now there are a couple conditions to this, so let's take a look at each of the conditions. So the first condition is if the population distribution is normal, meaning they tell you the distribution is normal in the original problem, then the distribution of the sample mean is normal no matter what the sample size is. Now the second condition is if the population distribution is unknown or we know that it is not normal, then the sample means will be approximately normal with a sample size of at least 30. So this encompasses the entire central limit theorem. So what we can do is we can apply that to what we talked about last video, which was finding the probabilities. But instead of finding the probabilities of, let's say, what is the probability of one person being taller than 70 inches, we could find the probability of a sample being taller than 70 inches. All right, so let's take a look next at what the mean and the standard deviation are of sampling distributions. So the sampling distribution, mean and standard deviations, here will be the first. The mean of the sample means is what this is saying. And to find the mean of the sample means, it will actually just be the mean of the population. So it's very easy to calculate the mean of the sample means. It is whatever the given population mean will be. The next thing is the standard deviation of the sample means. The standard deviation of the sample means, so our standard deviation of our sample means is equal to the population standard deviation divided by the square root of the sample size. All right, so from here, let's take a look at one example that will relate this information to what we were doing before. So let's say we take a population and we find that the mean number of hours that they study is 2.3 hours and the standard deviation we find is 0.7 hours. Let the sample mean equal the number or the average amount of time 10 students study. Let's find the probability that that average amount of time of those 10 students studying is less than 2 hours. So what we need to find here is the z-score for these 10 students. The z-score for the sample means is equal to the average of your sample minus the mean of your sample means over the standard deviation of your sample means. So this is the exact same z-score we've been working with. You have your data value minus your mean over your standard deviation. But here, we need to figure out what x bar is. In the problem, they tell us that we want to find the mean being less than 2 hours. So our x bar will be 2. We need to find the mean of our sample means, which is equal to the mean of our population, which would be 2.3. And then we need to find the standard deviation of our sample means, which is the formula, the population standard deviation divided by the square root of our sample size. So that would be 0.7 divided by the square root of 10. Which, when you go to calculate it, will be 0.22. Okay, now we go and put those in for our z. We get 2 minus 2.3 over 0.22, which gives us a z-score of negative 1.36. We are going to use this z-score now to find the probability on the chart, the z-table. So you go negative 1.3 in the column, and then on the row on the top, you look for 0.06. You find where the z-score meets, and the probability of the student studying less than 2 hours then would be 0.869. So this would be an example of how you would actually use the central limit theorem to find a probability of, instead of one person, the probability of a sample being less than or greater than something.